Welcome to today's session on capacity and cost optimization. My name is Cobus and I'm the Senior Developer Advocate for AWS for Sub-Saharan Africa. In today's session, we're going to be taking a look at how to optimize your cost as well as your capacity using EC2 instances and a whole variety of different purchasing options that you have available. We're going to specifically take a look at pricing optimization. Then we're going to move over to capacity optimization. Then I'm going to give you some guidance on how to run specific workloads. And then we'll move over to some workload examples that are very well suited towards making use of spot capacity. And then lastly, we'll conclude with a couple of key takeaways for you for the day. So firstly, let's quickly take a look at what AWS's infrastructure worldwide looks like. If you take a look at this slide at the moment, you can see that we have got regions spread across all over the world. And now just a quick definition clarification. When we refer to a region consists of 3 or more availability zones. One availability zone consists of 1 or more data center. And the reason for this is that we found that balancing services across 3 individual availability zones gives you a much higher uptime and less likelihood of interruption. So when you do see our stats online, just understand that our region means that it's got 3 or more availability zones. We currently have got 23 regions available and 73 availability zones spread all over the world. Moving on to EC2 instance types. When you look at an EC2 instance type, you'll see that it's got a name something like m5d.extralarge. And I just want to quickly explain to you what those different portions mean. So firstly, the first letter is an indication of the instance family. Now, in the case of this example, M stands for general compute, but you could also get something like C, which is the compute optimized ones. These are instances with high clock frequencies, but lower memory to CPU ratios. Then you also, for example, get the R family, which is memory optimized. They've got a much higher memory to CPU ratio, but they've got lower clock speeds. And this is just for different type of workloads that you want to run. The second value that you can see over there is the number 5. That indicates the instance family in terms of the generation that it's been. So the higher this number, the more recent this instance was released. Then after the number, you'll see there is either no letter or 1 or more letters. Those indicate additional capabilities. These are things like, for example, with a D, it indicates NVMe SSD storage has been attached, but it could also be, for example, with an A, that would indicate that it's using an AMD CPU instead of an Intel CPU. And then lastly, we've got the instance size, which is the t-shirt sizing that we have for our instances. They range from nano all the way up to 32 extra large. Now, when you look at a large versus extra large, the extra large is twice the capacity and size of the large in terms of CPU and RAM. And the 2XL will be double the size of the XL. And when you take these instance family types and then also you combine them with additional specific capabilities based on what you want to add to them. And lastly, you can add, for example, additional options to them like AWS's inference or elastic inference chips that allow you to run machine learning workloads up to 75% faster. You get more than 270 different instance types. And we look over the history of how we release these, you can see that we've created quite a lot of different instance families. And the reason for this is that 90% of our roadmap is driven by customer requests. So we created all of these different instance family types based on feedback from customers, continually pushing us to provide better and better infrastructure for them to suit their specific workloads. So now let's start looking at how you can optimize EC2 cost and capacity. And there are 3 sections we'll be looking at today. Firstly, we're going to take a look at pricing, how you can optimize around pricing with different purchasing models. Then we're going to move over to capacity and how you can blend different capacity types based on the purchasing options that you took to ensure that you've got sufficient capacity for what you want to run. Then lastly, we're going to go over to the guidance section where we'll show you how to do cost and capacity recommendations based on all the different options you have available. So firstly, let's start off with the pricing section. The first thing that I want to go over in a bit of detail is the different purchasing options that you have available for Amazon EC2 instances. Most people are familiar with the on-demand pricing option, which is where you purchase a specific instance when you spin it up. There's a per second running cost associated with it. And when you shut it down, you start being billed for that instance. This is typically how most people run them. Then the next one up is reserved instances. And this is where you know what kind of compute baseload you need. So for your steady state workload, then you would go ahead and reserve an instance and you would either pick 1 or 3 year term. And then also in terms of the pricing, you would decide whether you want to do everything upfront, a portion upfront, or nothing upfront. And depending on the combination of these, you would get a significant discount on the amount of compute that you reserve for. Reserved instances are also great to ensure that you always have capacity. So you can reserve capacity in a specific availability zone, and that capacity will then always be allocated to you. The next one is savings plans, and this is a new feature that we launched last year. And instead of asking you to decide what type of instance or instance family you want to reserve, you can say, well, I'm prepared to commit for a specific dollar value. And then based on what compute options you run, you get a significant discount, up to 72%. The last type is spot instances. And this is a very interesting one, and we're going to dig quite a lot into this type today. A spot instance is excess on-demand capacity that we have available in our availability zones, and we make them available to customers at a 90% cost reduction. There is a caveat, however, that if, let's say, on-demand surges and we need more capacity, you will get a 2-minute warning, and that instance will then be terminated. But we'll dig into that quite a lot later. When you combine these different purchasing options and you start thinking about how to optimize your cost, the best way is to actually make use of all the different types to get the best cost possible. So if you look at the very bottom of this little iceberg that we have, you can see that that would be the section where you know what your steady state workload is. So you know you always run this level of workload and never dip below that. That's where you would use either reserved instances or you would make use of savings plans to get the largest possible discount for that. Then what you have is the next layer is the on-demand layer. And this is for new workloads where you have stateful or spiky workloads. And you want to make sure that they are running and you can't handle interruptions there. Then lastly, you've got the spot layer at the top where you do your burstable fault-tolerant workloads. So let's say you've got some kind of API which is stateless and you suddenly have a spike. You would launch a whole bunch of spot instances to handle that additional capacity. And that's how you get the best blending of different purchasing options to optimize your cost on AWS. So now I want to take you through one of our customers. The customer is Deutsche Börse Group. They're a leading European financial infrastructure provider. And they are making extensive use of Amazon Spot instances. Their workload is such that it's highly regulated, so when they do release new features, they always have to make sure that it is running, and also they need to make sure that it's running at their performance requirements. Because this is used for trading, it needs to be very, very fast. And with that, they need to ensure that everything is working as expected without any faults. And what they did is they ran a whole suite of integration and smoke tests on their data and services that they deploy every single time they made a change. Now, previously they ran this on-prem, and that could take them days to run, and they used to have to schedule these over weekends to make use of the capacity that they had. They then started investigating spot instances in terms of the termination rates. And what they found is that by looking at the different instance families, that some of them were terminated more frequently than other ones. And what you can see on this graph is that they saw that, for example, the M5 4XL had a termination rate of about 5 to 10%, whereas the R4 2XL only had a termination rate of under 5%. And then what they did is they took all of these different instance family types. So they decided to spread them across different families of instances and run their smoke test. And what they found is that if you look at their peak during 2019 in March, they launched 4,532 spot instances, of which only 128 were terminated while running that smoke test that they were doing. They then also built a system to then, when the smoke test failed, to make use of on-demand instances. And if you look at the savings that they achieved with that, is even with the re-execution of some of their tests on on-demand instances, they were able to get a 75% cost reduction in terms of the instances they were running. So if you play around with Spot and your workloads can handle them, this is a very great way to actually make very large savings. Let's move on to savings plans. So as I mentioned, a savings plan is a dollar commitment where you tell us, I'm prepared to commit, for example, $2 an hour for the next 1 or 3 years. And then you decide on your payment option. So the reason we build savings plans is firstly, they're easy to use. You can receive the discount purely by specifying a dollar value that you want to commit to. You can get significant discounts. With savings plans, you can get between 66 or up to 66% or 72%, depending on which one of the two savings plans you pick from. They're also flexible in the sense that they apply across multiple AWS services, as we'll see in the next slide. So let's quickly differentiate between the two different types of savings plans that we are dealing with. The first one is the compute savings plan, and this is the generic compute. It applies to Amazon EC2, Amazon Fargate, as well as AWS Lambdas. So any one of those three or combinations of them, and if they're incurring costs, will be covered by your savings plan. And with these savings plans, you can get up to 66% off. When, for example, you look at the EC2 instance savings plans. This is where you commit a dollar value to a specific instance family. So you'll say, we want to define a base spend of $2 an hour for the M5 family type. And then it doesn't matter which different types of M5s you launch. If they're within that $2 range, the discount will apply to them, or they'll be included in that discount. If you want to see the full list of differences between reserved instances and savings plans, you can take a look at this grid that I have up here. Don't worry, we're not going to go into too much detail. We will make the slides available to you afterwards, so you can look at them in quite a lot of detail later. But the one thing I want to highlight here is if you look at the compute savings column on the left, you'll see that they give you the most flexibility and the most ease of use in terms of applying them compared to the other options available. So it's a very good place to start. Now, let's say you want to start with a saving plan. What you would do is you would go to the AWS Cost Explorer, and it'll actually guide you through the purchasing options. So firstly, there's a mechanism in there to allow you to get a recommendation of what savings plans we recommend, but you can then review and actually change it, and also customize what options you want to pick. For example, the payment term, is it 1 or 3 years? Do you want to pay everything up front or portion? And the portion can be anything between 50 and 99%. And then lastly, it'll show you exactly what the savings will be, and also it'll tell you what your amount is that'll be billable immediately, along with what your monthly cost will be over the period that you have selected. So it's a very easy way to see what you'll be saving. And then once you're done, you just click purchase, and then it'll get applied automatically to the resources that are covered by that savings plan. Now, Spot, when you combine Spot on demand and capacity reservations, that's how you get the most cost-effective, scalable compute savings available in terms of your setup. Remember that iceberg that I showed you? You really need to spend a bit of time to figure out how you want to split the different workloads in the different purchasing options. And it's, especially if you look at Spot, it's one of the easiest ways to optimize your bill on AWS. Now, digging into Spots a little bit more in terms of what they are and how they operate. So the first thing is that they are the same instances as we use for on-demand. It's the exact same hardware. It literally is just a different purchasing model because we are making use of the additional capacity we have available on our availability zones. Then the pricing, you can go look in the EC2 console at the history for the past 3 months on a per instance type to see how much they vary. But in general, it's smooth and infrequent changes. There's some instance types that have got a bit of spikiness to them, but overall, they are very, very smooth, and you can get a very good idea of what they will cost. You're also able to see this history, and also when you pick Spot instances, you can pick across the different instance types, so M5s versus, let's say, C5s. You can also pick the different sizes, so you can go, you might not just need a large, or you might need a 4XL. So there's a lot of usage options that you have available there. And also, the interruptions are actually infrequent. Over the past 3 months, we only terminated 5% of Spot instances across all our different regions. So in terms of planning for that, you can take that percentage as an indication of how frequently that would happen. Now, next question is, why would you use Spot instances? Well, the first one is that they give you low predictable costs. You can get up to 90% savings discounts with them. So like I said, there's a lot of money that you can save by using Spot instances. By saving that money, you can also get faster results, because remember, if you're running at a 90% discount, you can run almost 10 times the amount of compute for the same price as the on-demand price, which means you can get your results much, much faster. And then lastly, they're very easy to use. We've integrated them into a whole list of services in AWS, some of them being Amazon ECS, EKS, SageMaker, EMR, as well as AWS Batch. So in a lot of cases, it's simply flicking a switch or adding a configuration option for them to be making use of Spot instances. Now, when Spot instances do terminate, you have to think about how do you want to handle that termination. So how it works is that you get a 2-minute warning on the API or in the instance metadata that tells you this instance is about to be terminated. And then you have 2 minutes to decide what do you want to do with the running workload that you have there. For example, in the case of Amazon SageMaker, when you use Spot fleets, you can enable checkpoints. And what this does is that while your model is training, we take checkpoints as we go along. And then when the Spot instance is terminated, it'll wait for capacity to become available again. And when that capacity is available, it'll continue from the checkpoint. So you don't have to start training your model from scratch again, because that'll take too much time in terms of, if you think of training your model, you just spent, let's say, 3 hours training it, and now you lost all the training. So you will not lose that training. Use checkpointing. Then if you use, for example, our auto-scaling groups, we've got the ability built in to start auto-draining connections from the instances that we want to terminate. So let's say you've got web requests coming in. As soon as that Spot instance gets a notification of being terminated, it notifies the load balance, and the load balancer stops sending requests to it. And then the requests that are currently in flight will continue to process as normal until they complete, or until we reach the 2-minute mark, and then shut down the instance. You can also, for example, use the stop, start, or hibernate features of instances to actually have them continue their work a lot quicker when Spot instances become available again. So just to clarify there, let's say you've got a Spot instance running a specific workload and you receive that notification. You can build in some automation around that to take that notification, shut down that instance, and then wait for capacity to become available. When it's available again, you just resume that instance if it was hibernated, or just start it up again. It'll even have the same instance ID as before. So it's a really easy way to continue working when you did have an interruption. So when you think of using Spot instances, there are 3 things you have to think about if you want to use them successfully. The first one is instance flexibility. So when you're running workloads on, for example, M5 large, that has got a certain configuration, let's say 2 CPUs and 4 gigs of RAM or 8 gigs of RAM. You can then look at other instance families that have roughly the same characteristics. For example, it might have 2 CPUs, but then let's say 16 gigs of RAM, but the pricing is very similar. Or it's got 4 CPUs and 8 gigs of RAM. Depending on the different family types, you can get a lot of different instances that are close in terms of the requirements that you might have. Then in terms of time flexibility, certain workloads can be run in an interrupted fashion, others can't. So for example, let's say you've got a web request coming in. That's a time-sensitive workload. You don't want to interrupt that and finish processing it at a later stage. Whereas you might have time-sensitive workloads, for example, machine learning training. If that training job, which tends to, let's say, take 5 or 6 or 8 hours, is interrupted for half an hour or 20 minutes, you probably won't notice that in the scheme of things unless it's something that's very sensitive. But in general, look for workloads that can be interrupted, because those are very, very well suited towards Spot instances. Lastly, also look at region flexibility. So let's say you will have a very specific requirement for a very specific instance type, like some of the P family or instances that are used for very high intensive machine learning workloads. You can look at the different regions to see where the most capacity is available to allow you to run it. So if you can run your workload in a different region where that instance is, the Spot capacity is available, look at how you can actually shift your workloads between the different regions to get the best out of Spot instances. And then just some of the companies and different industry verticals that actually make use of Spot. You might actually recognize some of these logos over there. They have successfully used this and have been able to get those massive cost savings. Now we're going to move on to the next section, which is the capacity management. Now, the best way to actually optimize capacity is to figure out when your instances need to run. And a very easy way to do this is if you, for example, look at, let's say, a production workload, that needs to run 24/7. But let's say you've got a testing UAT or some kind of staging environment. That doesn't need to run all the time. That might only need to run, let's say, for work days. So from Monday to Friday, and it still runs 24 hours a day. That will already reduce your cost by almost 30%. Now, if you get a little bit more smart about it and you, let's say, only run for 12 hours a day, from, let's say, 7 in the morning till 7 in the evening, or if you reduce it even further, just running 10 hours a day, from, let's say, 8 a.m. till 6 p.m., you can save more than 70% of your cost just by switching the instances off. And there's an easy way to do this by making use of the AWS Instance Scheduler. And you can see the link at the bottom in terms of how you would deploy this inside your account. And this instance scheduler allows you to configure how and when you want to switch instances or RDS instances on and off. And it's a very, very easy mechanism to get savings without any other kind of complications. Now what I'm going to do is I'm going to take you through Amazon EC2 auto scaling in terms of how you can use it with Spot instances as well as different instance family types. So just quickly, you can use a very different ways to optimize in terms of the auto scaling group. The first one is capacity optimized, where you pick where there are the most available capacity for Spot instances in a specific availability zone, which means that you've got the least likelihood of getting that 2-minute termination warning and your instances being terminated. Or what you can do is you can optimize for the lowest possible cost. So go for the lowest cost for whatever workload you want to run. And we can create a prioritized list in terms of the type of instances we want to launch, as well as how to split between on-demand as well as Spot. So let's take a deeper look at this. So first thing we have to cover is what a Spot instance pool costing works. So what we see in this grid is that I'm looking at the C4 family type, and I'm looking at the different sizes between large and 8XL. I'm also looking across 3 different availability zones, 1A, 1B, and 1C. And then what you see in the block there is the price of the spot instance, the spot pricing for it at the moment. And also then in the green column, you can see what the current on-demand pricing for those instance types is. So just note that the pricing for spot does differ between availability zones, as you can see in this grid. So firstly, we're going to be taking a look at the C4 family. Then we're going to take a look at the different sizes of that type of family. And then we've got the different availability zones. And then what you need to focus on is that this price changes in every single region. So when you look at a specific block, remember that it's for a specific instance family, instance size, as well as availability zone. And this is a instance pool. And then also this pool price differs across the different family types that you're dealing with. So let's quickly jump into this specific example. Let's say we want to do a capacity optimized strategy. So what you can see here is 3 different availability zones, and you can see the different instance family types color-coded. We've got the R5 large, M4 large, M5 large. And what you can see is because we're going for the capacity optimized allocation strategy, we will choose the one with the largest capacity pool represented by the bar on the right of the instance type. And we can see that we want, in the first one, we're going to pick the R5s because we've got the most capacity. Second one, M4, most capacity. And the last one, we will go for the M5 in terms of the capacity available. This is useful if you want to reduce the amount of interruptions. If you, however, want to optimize on cost and you want to go for the lowest price strategy, you can see the number of dollars on the left of the instance indicates the cost relative to the other instance types. And over here, you can see we optimize to pick the cheapest instances. And also worth noting over here is that the lowest price doesn't always correlate to the least amount of capacity available. There's no direct correlation between the two in terms of the pricing at the moment. Obviously, when that pricing goes up and the capacity becomes low, then there's a slight correlation there. So when you think of what instance types you want, you need to be able to specify the different allocations strategies that you apply. So with auto-scaling groups, where this becomes super interesting is that when you scale up, you can use this new configuration to decide what instance types you want to spin up. Because remember, what we're going to be doing is we're going to be blending different instance family types, and we're going to dig into a bit more detail in it in the next few minutes. But when it starts up, you can say that I prefer spinning up an M5 large over an M5 2X large. And if that capacity is available, the auto-scaling group will scale up with that preference in mind. Then also when it scales down, it takes that preference into account and sees, well, can I scale down the M5 2XLs before I scale down the M5XLs because of my load that went down? So we've built this into the auto-scaling groups. And I remember we want to create this iceberg of different types of purchasing options when we want to run it. Now, we want to make that easier for you. And let me show you how to do that. So initially, we had auto-scaling groups. And if you wanted to combine different instance families, you would have to create a auto-scaling group per instance family that you wanted to run with. Obviously, this was a lot of configuration and not as flexible and required a lot of work from our customers. So we got feedback and we made it easier. We made it so that you can actually combine the different instance families inside a single auto-scaling group and decide how to use that. Then the next feature that we've introduced recently is the ability to add weightings inside this grouping. Now, if you look at this graphic that we have over here, you can see that we are making use of M4XL, M4 XXL, M4 4XL. Now, if you think of your workload that you're running, if you're running that workload on, let's say, your desired instance, the M4XL, that can have a weight of 1. And then when we've got an instance that's double the size, you give it a weighting of 2 because you expect to be able to run twice the amount of your default workload on that instance. Similar with the 4XL, it's double up again. So in other words, you should be able to run 4 of them. And why this is important is that we can now take that into account when we launch instances. So if there isn't capacity available for the M4X large, we can make use of the, let's say, M4 4X large, but that will count 4 towards the desired capacity for our auto-scaling groups that we're going to be dealing with. So just quickly to show how we're going to use that, how we use that in configuration is we're going to take that same instance pool that we used previously, but now we're going to add the weighting to it. So because of the sizing difference, you can see those are the weights we apply. And then when we start looking at the weighted price, we can see that the on-demand weighted price is exactly the same as you would expect. But then when you look at the spot pricing, when taking the weights into account, you can see that there are different places where there's sweet spots where it's a lot cheaper to run using that specific spot combination and that family combination in that specific availability zone. And I'm just going to quickly show you what the API looks like for that. So firstly, you would define the instance types you want to do and specify the weightings that you give them. You'd also specify the minimum and maximum and desired count that you want on your autoscaling group. Then what you would do is you would say that you would use the on-demand allocation instance strategy called prioritize, and this is the only one currently available. You would then define the on-demand base capacity. So in this case, we say we want at least 10 of those desired instances to be on demand. And then what you do is we specify a percentage of how do we split between on-demand and spot for the rest of the capacity between the on-demand base and the desired that we want. And this is how we run between the two different types of purchasing options. Then we've got the spot allocation strategy. And this is where we can choose those ones I showed you, either the capacity optimized or the cost optimized, depending on what your workload would want. And then lastly, this last configuration, the spot pool instance pools, defines that in that override list that we provided of the different instance family types and the weighting, we can define how many of those to use. And I'll start using from the top. So if I specify one only, the spot instances will only look at the M4 extra large instances. But with two, it'll look at the first two in that list. And this will then allow you to create this blend between on-demand as well as spot instances and combine them all in one easy auto-scaling group with whatever strategy you prefer. There are also a lot of third-party integrations that you can use with spot instances as well as EC2 scaling. And you can see over here in terms of what AWS already has out the box that's working and also which of our third-party integrations are available. Now, we're going to take a quick look at the guidance that we give customers in terms of which instances to pick. So for those not familiar, we've got a service called AWS Compute Optimizer. And what Compute Optimizer does is it actually looks at your workload, analyzes it over the last 2 weeks, and then makes recommendations on instance sizes and quantities for you based on what you used to run. So how it works is that Compute Optimizer has uses machine learning based off millions of workloads that we've analyzed of what customers are running. So for example, when you have a spiky workload where, for example, for some reason on Fridays you spike, we will take that into account when we make recommendations of your instance sizes. And then what it does is once it has analyzed your workload, it'll give you a recommendation between your EC2 instances or your auto-scaling groups in terms of increasing quantities or even changing to different family types. So it might pick up that, listen, you're currently using a C5, but you don't have a very compute-heavy application. So rather use an M5, which is general purpose one. So it'll make these recommendations, but it won't make any changes to your service as it's running. So what we'll show you next, what you can see at the bottom, is what this actually looks like. So let me quickly show you. So this is a view of the Compute Optimizer, and you can see there the recommendations that it makes. So once again, it'll make the recommendations, but it won't change anything in your account. Next, I'm going to show you some workloads samples on AWS. And as you can see, there are quite a lot of different ones you can run because AWS is built to run anything from databases to DevOps to IoT to machine learning. We're only going to be taking a look at a subset, so 3 of them. So the first one I want to go over is machine learning. Like I said before, in Amazon SageMaker, there is a feature that you can enable to make use of spot instances for training. And that's all you need to do. You need to then configure the checkpointing. And then once that's enabled, SageMaker will use the spot fleet for training. And you don't have to spin up any of the infrastructure underlying or deal with the difference between spot and non-spot or handle that complexity. SageMaker will take care of it for you. The next one I want to show you is on the DevOps, the CI/CD workload, is if you use something, for example, like Jenkins. Now, I use Jenkins as my first CI/CD back when it was still called Hudson. And Jenkins is actually a very good example of how you can split between the master running and then having multiple worker nodes execute your code using spot instances. And it's automated with a plugin inside Jenkins. So what that would look like is you may have your Jenkins master running behind a load balancer. And that'll typically be on-demand or reserved instance because you want your master to always be available. And then Jenkins would spin up spot instances based on the number of jobs that are currently running or the amount of, let's say, if you want to pre-scale, if you know in the morning at 8 a.m. a lot of people start kicking off jobs, you can configure the job to actually spin up these spot instances and then make use of that massive savings by running the workloads on there. Then the third workload I want to show you is where you run websites and web applications. Because if you think about containers, they tend to be stateless already, so they're a very good candidate for making use of spot instances. And because spot instances are already integrated in both Amazon ECS and EKS, you can make use of them very easily by just configuring them similar to the autoscaling group that I showed you just now to get the best use out of the Spot instances. Then also just quickly to highlight, you can use Spot with Fargate as well. Now Fargate is the ability to run a container without having to manage the underlying host. So you specify the memory and the CPU requirement, then give us a task definition with between 1 and 10 containers defined in there, and we will go find where to run it. So now you can specify to run your containers with Fargate using Spot instances as well, and you can save up to 70% of the regular cost of that. You're able to also balance between the on-demand as well as the Spot of Fargate in the configuration when you do spin up your service. So quickly, rounding it all out, by tying it all together, the 4 key takeaways that I want for you to have today is the first that goes experiment and see where you can make use of Spot instances, because they can save you quite a lot of cost in terms of the workloads that are interruptible. Secondly, go look at how you can combine autoscaling groups like I showed you with the different types of instance family types along with the Spot instances, because if you combine all of that and then also make use of savings plans for that base on-demand capacity that you need, you can actually get quite a lot of cost savings on your account. And then also, please use the compute optimizer, because you want to use best practices to right size your workloads on your EC2 instances, because that's also a very easy way to go ahead and save costs. And then lastly, you need to get technical and get technical guidance from AWS. We've got something called an immersion day. An immersion day is where we'll sit down and take you through the different technologies and work with you to help you understand. And please ping either your solution architect or your account manager and ask them about how to schedule these immersion days, because that's one of the best ways to get quick upskilling of what's available on AWS for you. Then lastly, if you're interested in training, we have got more than 20 free digital courses available, as well as a training and certification path that you can see on aws.training. Like I said, these slides will be available afterwards to you, so you can get these links out of that. And with that, I hope you found this session useful about how to do capacity optimization using Spot instances spread between the different instance families that you have. Again, if you want to contact me and you have any questions, please connect with me on either Twitter or on LinkedIn, and I can take some more questions afterwards. Thank you.